Hello, everyone. A very good evening to you all. This is Arjun Avadani, and I'm going to be conducting this workshop, the A to Z of recommender systems. So, this workshop is in collaboration with the Ingenious Hackathon. I hope all of you guys have registered for the hackathon as it is shaping up to be a very good event. So, let's delve right into recommender systems. So, the first thing which I want to tell you guys is what is the overview of this workshop. We'll start off with a general introduction. Since this is a very beginner friendly course, it's important that all of you guys get an idea of where recommender systems are used, why it's used, and so on. We also want to see what is the characteristics of a good recommender, what it takes to be a good recommender essentially. We also want to look at an overview of the types of recommender systems. We won't go into all the types, but we will go into two types particularly which are commonly used in the industry, and that is collaborative filtering and content based filtering. We'll also go into a practical example. And as I mentioned before, this is a very beginner friendly workshop so that maximum of you guys can understand. We have chosen a very simple recommender system topic, which is the book recommender system. Most recommender systems are used in book recommending, movie recommending, and so on. So we have chosen that topic and we'll delve into it a little later. It's important to note that recommender systems is an important topic under machine learning. And since some prior machine learning knowledge is required, most courses today keep recommender systems as one of the last lessons. However, I've tried to make this workshop as easy as possible so that even a beginner can understand. So let's delve right into it. So now starting off with an introduction. So recommender systems are a huge business and there are tremendous amount of money and personnel involved in it. Well, this is fairly obvious. We see recommender systems in every single strata of society. We see it in various websites. We see it even when we're just generally talking to someone, when we're recommending something. So, a lot of the big companies do use recommendation algorithms and they do pay big money for it. So, an example of this is what happened in 2009 with Netflix in particular. So, Netflix in 2009 announced a $1 million cash prize. So they announced a $1 million cash prize to anyone who can improve their recommendation model by just 10%. So 10% improvement is all they were looking for, and they were giving such a huge cash prize. That just shows how important and valuable it is to them. So even basic recommenders are said to offer a 20 to 25% more profit in large companies than if they do not use a recommender system at all. So a basic one itself can fetch you a 20 to 25% more profit by using these. So this is just a general definition. The recommender system or a recommendation engine or a recommender system, all of these synonyms, they're basically a system that provides suggestions for items that are most useful and relevant to a particular user. As we go deeper into the workshop, this will become more clear. So, as I mentioned before, every single application in every single strata, they use some degree of recommender systems. So, Amazon, I'm sure all of you guys have seen Amazon recommending you various items. It's pretty common that when you buy an item, Amazon will usually have a section called users who bought this also bought, and they'll show you a bunch of recommended items. All of these work on recommendation algorithms itself. Netflix, of course, uses recommendation as well. I've in fact put a picture of that over here. So here you can see top picks for Joshua, and you can see because you watched Narcos. So now this we'll come back to this a little later because it's a good example of one of the topics which we're going to be seeing. So you can see that based on the user Joshua, Netflix is capable of recommending some new shows and movies. And based on the item, here we're considering movies as item. Items are the entities that are being recommended to a user, and user is the entity to which items are recommended. Yeah, so because we watched Narcos, it's recommending a bunch of other movies and shows that we can watch. And then, of course, you have it in Google News. Various news articles will be recommended to you based on what you have previously searched. Facebook friend recommendations are also very commonplace. Facebook is one of the largest users of recommender systems as well. So, yeah, we'll see all these in detail as well. So this is just a simple little graphic that I've taken from various online sources. I've taken a bunch of graphics throughout this workshop. So this is a graphic where they're just showing like a basic thing of what happens in Amazon. So customers who bought this item also bought, and they're showing various other food products that the customers bought. So this graphic basically depicts what Amazon and other large e-commerce websites do. So this is not something which is restricted to Amazon. all of your websites always recommend different items to users based on what they've previously bought. It's a very common thing to do. So this is just another example, continuing the same. Another thing is I've mentioned next to some topics headings, I've said that this is a highly researched area. So in the future, if you guys want to do some research on recommender systems, those are some areas which you can research. Throughout the course I've added things like that. Okay, so now coming to what is the goal of a recommender. So of course the first goal of a recommender is we should uh, you know suggest items that the user finds interesting. That is basically what relevance means. Of course, if the user is a huge comedy fan, then we should try to suggest movies that are of good quality with respect to comedy and pique the user's interest. And then of course we have novelty, which is a very familiar thing with respect to every single algorithm that's used. The recommended item should not be something that the user has already seen in the past. It should be something new. It should be something that the user will be interested to click on. So yeah, this is a good example. Popular books of a genre that user likes would usually not be novel to the user, right? Because he would have already seen it before. And then we have serendipity. So here, these are items recommended are somewhat unexpected. So this will induce some amount of lucky discovery. Yeah, so the items that you are recommending, well, it should not be something which is very repetitive. There should be some form of a lucky discovery or some randomness that is thrown into your recommendation so that, maybe the users might click on it and might develop a new trend of interest in that. They might be like, okay, fine, this is actually cool. Let's watch more of these kind of movies or something like that. And of course, novelty, serendipity, and increasing recommendation diversity, all of these goes hand in hand. So the user should not get bored by repetition of similar items. So yeah, this is another example. If a user likes some particular singer a lot, like Ed Sheeran, it's useful to have a random periodic recommendation of Eminem because they have completely different types of music. So this induces diversity, and maybe this can increase the kind of variety of music that the user likes. So it could be beneficial both ways. So now this flowchart explains the various kinds of recommender systems. So we'll be looking at collaborative filtering and content-based filtering in depth. Hybrid methods we will not be looking into in this workshop because we don't have that much time. But it is a growing area of research. Apart from these three, there is an other important recommendation system called knowledge-based recommenders, and those again is a good thing to look into. But we will not be going into it this course. Uh, you can post in the comments if you guys want any extra material or if you want the link to any of the code that I'll show you guys later on, and I will send it on the comments. So no worries about that. So collaborative filtering is divided into the model based and we also have the memory based. Both of these we'll be seeing in detail. Memory based is further divided into user based and item based as well. So yeah, here memory based will be seeing into great detail. Model based, since this involves some amount of machine learning algorithms, we won't be seeing much into it now. But we will. But I can send you, as I said, I can send you guys some material related to it or some of the code links to it if you guys want. Just ping me in the comments. So now this is a classic example that is used in many different recommendation courses and even textbooks and various college courses as well to explain collaborative filtering. So now, first of all, what is collaborative filtering? Rather than looking at the definition, look at this diagram first. So now this explains the user-based filtering. So what they're saying is that, say this is some user, say Alice, and this is some user, say Charles. So these depict that. Somehow it's been established that Alice likes grapes, strawberries, watermelon, and orange. Now look at the arrow marks from Charles. Charles likes strawberry and watermelon. Now the recommendation algorithm has somehow found out that Alice, who's up over here, and Charles are similar. Now, this similarity could be found out on various different parameters. Maybe they were looking at the kind of past sales history that has been done with respect to both their accounts or something like that. But the recommendation algorithm has found out that Alice and Charles are similar. So now, since they're similar, whatever things Alice likes can be recommended to Charles and will be by the algorithm. Similarly, whatever Charles likes will be recommended to Alice. So you can see that here, since Alice likes grapes, strawberries, watermelon, and orange, and here Charles he likes strawberries and watermelon. So now grapes are being recommended to Charles and orange are being recommended to Charles as well, because both of these have been liked by Alice and it's been established that Alice and Charles are similar. That's what this arrow depicts. So that is how user based filtering works. They look at the similarity between the users. So that's what the definition says. The ratings are provided by like minded users of some user A, and these are used to make recommendations. So yeah. So similarly, you suppose if we establish that here Alice is similar to, let's say this person is it's a girl, so let's say it's Barbie or something. So if we have identified that Alice and Barbie are similar users, whatever Alice likes can be recommended to Barbie, and whatever Barbie likes can be recommended to Alice. It works two ways. So that is user-based filtering, where we're filtering on the basis of the user similarity. Now we come to the item-based filtering. So here we see again the same interconnection, the same likelihoods of the arrows and all that kind of stuff. Everything is the same as the previous diagram back over here. So here by some the algorithm has somehow established that grapes and watermelon are similar to each other. Maybe they're similar in terms of the nutritional content. Both them probably have similar nutritional content, but the algorithm has established that they are similar. So now since they are similar, whatever Alice is, whatever whoever likes these, watermelon. So here you can see that watermelon is liked by Barbie. It's liked by, yeah, as I mentioned, this is Barbie, and it's also liked by, let's say, Alice. So no, so let's say that these two are similar. Now since watermelon is liked by Barbie, and somehow and watermelon is also liked by Alice, grapes can be recommended to both Alice and Barbie. So, as I mentioned before, these two are similar, and since watermelon is liked by this Alice and Barbie, both of them, and grapes is similar to watermelon, we can recommend grapes to both of these, is what item based filtering says. So, I hope you guys understood. We'll take a few other examples later as well, but for now, this is just a crude explanation of the two different methods. And as I mentioned before, the ML based method, we won't be looking deep into it right now because it involves machine learning algorithms and it'll take a lot more time than what is stipulated to us. So, yeah, so now we have one problem in the collaborative filtering method. The problem is here you can see that your Alice and Charles and Barbie, all of them work on the principle of past history. So looking at the past history of Alice and looking at the past history of Charles, both of them have been found to be similar. Okay. Similarly, here we can see that grapes and watermelon, looking at their various attributes, they're found to be similar. But now the question arises: suppose a new item comes or a new user comes. The new items have no past ratings and the new users have no past history. So without any past history, how are we going to be able to find out similar users and similar items? Because we're looking at the past, right, to find out similarities. That will not be possible. That is what the cold start problem deals with. It's a highly researched area, as I mentioned before. So as I said, like suppose I create an account on Netflix and my name is Arjun. Now, since I'm brand new to Netflix, I don't have any past history associated with me. So now, how does Netflix know what kind of things to recommend to me if it doesn't know my past history? That is how. So usually, modern applications like Netflix, they'll just deal with this by recommending the most generic things. But if we're seeing a more specific recommendation algorithm and not something as general as Netflix, then how do we deal with it? So that is why it's a highly researched area. If you guys want to see how well researched it is, you can just go to Google Scholar and type research papers related to cold start problem. You'll see a ton of research is done on it, and this graphic is just explaining the same thing. Right, so now to recap, the question that I want to ask you guys in this recap is, which of these two is item based filtering? Well, it's pretty simple. Here we have, as I mentioned before, the users are the entities to who you are recommending, and the items are the entities which are being recommended. So here you can see that Goodwill Hunting will thus form an item because it's a movie and it's going to be recommended to a user. So since it mentions the item here and the filtering is being done based on this item, because we watched Goodwill Hunting, these different movies are being recommended to us because of Goodwill Hunting. So maybe Goodwill Hunting will have some similar attributes with respect to all these different movies, and the recommendation algorithm has found that out, and it will be recommending similar movies to Goodwill Hunting to us. Now let's go back a bit up here. So here we can see that we have topics for Joshua. So now here we are filtering based on the users. Why do we know this? Because what Netflix probably would have done in this case is that it's seen who are the similar users to Joshua. The similarity could be determined in terms of maybe the past history, as I mentioned, or they could be determined in terms of how much watch time uh, Joshua spends on a particular class of movies. So, using that past history, various new movies have been recommended, new movies and shows. So, we have Breaking Bad, we have New Girl, The Fosters, all these different things have been recommended. Now, if you come down over here, because you watched Narcos, now this is similar to the Goodwill Hunting example I gave earlier. So, Narcos is an item. So, because of the similarity of Narcos with these different shows, they have recommended the shows and the movies to us. So, this is item based filtering and this is user based filtering. I hope you guys understood the difference. Again, if you guys have any doubts and you wanted to get it clarified, please ping me in the comments and I will, if you guys need some more material, I have it. I'll send it to you guys as well. Yeah, this is so right now we're just going through the conceptual parts of recommender system. So this is another like the core star problem, this is another highly researched problematic area in recommender systems. So yeah, the thing is, this section, what do you say, this is the x-axis, right? So let's say that this is the x-axis and let's say that this is the y-axis, your normal coordinate system. So yeah, so now the thing is, the popularity is being measured on the y-axis and your x-axis is measuring the this thing, products, like what are the various products and how, like, so suppose here, let's take the example of shoes, right? So here, let's keep Nike over here, Adidas over here, Puma over here, and maybe Reebok or something. So now these are the very popular brands, and they're occurring over here, which by the graph we can see that they have a very high popularity, right? They have an extremely high popularity because, well, from the graph we can infer that. But maybe a few lesser known brands, let's not take names, but a few known brands might be occurring over here. And you can see from the graph that they don't have a very high popularity. It's like tailing off towards the end over here. So a few very popular brands enjoy a lot of the spotlight, as you can see from the graphs, whereas a lot of less popular brands don't get enough spotlight. That is what's forming this long tail kind of graph over here. So yeah, so that's what the explanation says. Popular sportswear brands like your Nike, Puma, Adidas, all these are going to be rated highly on various applications like Mintra and so on. So these form the hits, but the other unpopular brands, which are larger in number, get way fewer purchases and they form the long tail. So the system should not end up, just going by popularity and recommending only the popular brands again and again. So, as I said before, the system should be capable of recommending maybe one or two of these lesser known brands to spark a new interest in the user. So, all of these are just some goals that your recommendation system should follow. And I just want to mention that all the content I've taken from, like not the explanation, but some of the diagrams and so on, I've taken from Harvard CS50 course, then Stanford's machine learning specialization, as well as a textbook on data analysis. So just want to give them credits for the graphs and the diagrams and the various pictures and so on. So now the thing is, how do we? So now, okay, until now, I've said a lot about similarity. Here, this entire graph or these two pictures were all about similarity, similarity between items, similarity between users, and similarity. But how do we actually calculate the similarity? And that is what we're going to look into here. So now, how do we actually compute similarity? That is, how do we actually determine how similar the users are? Now, one way of doing that is, so computing similarity, one way of doing that is nothing but your cosine similarity. cosine similarity. So I hope you guys all remember the formula for cosine similarity if you've come across before. So let's say that we have two vectors A and B. The cosine similarity between these two will just be A dot B divided by the magnitude of both. So yeah, this is a formula which we've all come across in maybe in our schooling years or something to calculate cosine similarity, and it is an important similarity metric in data analysis. So as I said before, this is a very beginner friendly course. There are other ways to find similarity, but things like cosine similarity and maybe your Euclidean distance. So we all know what Euclidean distance is. It's a major part of coordinate geometry, and Manhattan distance, and various other things like Jacquard similarity and so on. These are some of the things that are used to calculate similarity, more basic things to calculate, your similarity between two users and so on. And they're also taught a lot more in college courses than the more complicated similarity metrics. But these do work well, and for now we'll stick on to cosine similarity because that is what we use in the practical example that I have given you. So here, as I mentioned before, in the user-based example of a collaborative filtering, that is this, I told you guys that um, this is Alice and this is Charles, and they have somehow found out that Alice and Charles are similar to each other. So now cosine similarity actually helps us find out how that is happening. How do we find out they're similar to each other? So that is all found out using these similarity metrics, out of which cosine similarity is the example which we are looking into. So now the thing, okay, yeah, first of all, this table, we call this as a, this is called as a user item matrix. So that is because this column, all of this are users, and all of these, this entire thing, these are items. Okay, so this is a user item matrix, and everything in between, the three over here, the four over here, the three over here, and so on. All of these things are all the ratings associated with those items that is given by the user. So let's say Bo. Bo has rated Grapes of Wrath 4. This scaling could be something like 1 to 5, it can be 1 to 10. It's very easy to specify the scale in a data analysis or machine learning project. There's a lot of built-in functions. So yeah, you can just check that out. So here they seem to have used a scale of 1 to 5. So now if you want to calculate the cosine similarity, let's say that you want to calculate the cosine similarity between Anna and Bo, right? So let's just to simplify this, let's use the concept of vectors which you guys are familiar with. So let's say here Anna is A vector and Bo is B vector. So whatever is unrated, ignore it. So you can see that all these crosses, they denote that Anna has not rated Scarlet Letter. Similarly here, Freddy has not rated Grapes of Wrath. So that is what the crosses denote. Just ignore those crosses. For cosine similarity, you have to assume, move items that are co-rated by the users. By co-rated, I mean both them should have rated it. So this is co-rated, this is co-rated, this is co-rated, this is also co-rated. So all of these will ignore like whatever is not co-rated. Of course, actually using cosine similarity, there is a method to find out the value of unrated items, but we'll not go into that now. We'll just see how to calculate the cosine similarity. So let's put this all in the form of a vector. So we have, let's say this is 5i cap plus 3j cap. This is for Anna, right? Plus 4k cap, and let's just say one, let's call this m cap, just random dimensions, random vectors, sorry. And similarly for Bo, we have 4 I cap. So both the you can see that both of these are similar because they occur at the same location in the user item matrix. It's important to take care of that. That shows that they're correlated. Plus 5 J cap. Sorry for the bad handwriting, but yeah, 3 K cap and 2 M cap. So now all you have to do is just take these and substitute in the formula that is given all the way up here. So you know how to calculate the dot product of two vectors. It's going to be 5 into 4, that's 20. So 5 into 4 is 20, plus 3 into 5, which is 15, plus 4 into 3, which is 12, plus 1 into 2, which is 2. divided by the magnitude of both of these. So for the magnitude, you have to just do 25 plus 9 plus 16 plus 1. So that is the magnitude of A. And similarly, we have to calculate the magnitude of B, which will come over here, magnitude of B. So yeah, once you calculate all this, you can substitute the answers, and whatever you get is going to be your cosine similarity, guys. So usually, the thing to note is that the cosine similarity will range from -1 to 1, and 1 denotes that they're highly similar, and 0 1 sorry -1 denotes that they're very dissimilar, of course. So they it ranges from 0 from -1 to 1. Okay. So far we've seen collaborative filtering. So all of this was about collaborative filtering. I hope you guys understood this example properly. It's a very simple basic example to understand collaborative filtering. So I mean, if you guys still are not understanding collaborative filtering, I can give you another example. So let's say that I am Arjun, and let's say that there is some other user B. So let's say that Arjun likes uh, Interstellar, and let's say that Arjun likes Inception. Let's call this IN, and Arjun likes Shutter Island. So these are three movies, and also we can say that B. So okay, here B likes Batman, the Batman, and it also likes Man of Steel. Let's call this MS, and it also likes the Avengers. Let's call this TA. So now are these similar? Is so now seeing if the items are similar will be what an item based filtering method does. So let's say that so here this is Interstellar, right? And here we have Batman, we have Man of Steel, and we have the Avengers. That is these three. And here we have Inception, and here we have Shutter Island, and here we have Interstellar. So let's say that maybe in some parameter, let's say that Interstellar and the Batman are similar, maybe in terms of the total runtime, like how long the movie is. It's just a random example, guys. I know that in reality, you can say that they're dissimilar movies, but I'm just taking a random example. So since I and B are similar, we can use this to perform our item-based filtering, as I explained before. Okay. So since B likes the Batman, and it's found out that Interstellar and the Batman are similar, we can recommend Interstellar to B. And for your user-based filtering, if we find out that these two are similar, then whatever is liked by B can be recommended to A, and whatever is liked by A can be recommended to B, and vice versa. Basically, what I've just said is a recap for your user-based and item-based filtering. So now we're going to move on to content-based filtering. So content-based filtering is a little different than your collaborative filtering. So one major advantage of content-based filtering is that it overcomes the cold start problem. So as I told before, cold start problem is a highly researched area, and it's a nagging problem in recommendation systems. It's overcome to an extent, like it's just a partial overcoming done by the content-based filtering. It overcomes the cold start problem from the item point of view. However, the cold start problem for new users is still existing in content-based filtering. But for items, we have removed it. So if you guys forgot what cold start problem is, just take a look at this slide. Right. So now, coming to content-based filtering. So now here, this content-based filtering is going to exploit scenarios wherein the items can be described with a descriptive set of attributes. So these items are going to try to match users to items that are similar. Okay, yeah. So let's take the example of this shoe. Let's say this is A and this is B. So how do we, perform content-based filtering on this? One way of you guys visualizing this, how these two are found to be similar, is by assuming that all the properties of the item in question, that is product A and product B, they are going to be the attributes are going to be listed in the form of a key value pair. So what I mean by that is, suppose we have product A here and we have product B over here. Let's say that for A, okay, let's make key value pairs. Let's say brand as one key, and we say this is H&M, H&M, and color of sole. This is not the entire shoe color, but just the sole's color. This is white. And then similarly we can say that these are a size 8. Okay, now that's for product A. Now let's say here the brand similar, we have to take the same key value pairs. Let's say the brand over here is let's call it Bata, and let's say that the color is going to be the color of the sole, that is it's again going to be white, and the size this time is going to be a 7. So now all of the products attributes have been broken down into these kind of key value pairs, and using these key value pairs we can measure how similar A and B are. So we can see that the brand differs, but the color of the sole is the same. The size is almost similar. So using these metrics, we can see how similar those two different items are. So that is why the definition of content-based filtering is saying that it's exploiting scenarios where items can be described with a descriptive set of attributes. All the items that are in question will be described with a descriptive set of attributes, and the systems are going to try to match the users to items that are similar to what the user has liked or viewed in the past. So now suppose if I, Arjun, have bought an H&M pair of shoes in the past, looking at the algorithm will be able to compare how similar A and B are, and if the algorithm has found out that this is similar to this, like A is similar to B, then Arjun will also be recommended B. It's something like that. So again we can find out the similarity by using cosine similarity. In this for content based filtering, I'll just show you guys an crude very easy way to find the similarity. But yeah, this is the general introduction to content based filtering. And the one main application of it is situations where you have a large amount of information at hand. Of course, the more information you have at hand, the better you can make key value pairs out of it. So suppose if I had, some, let's say that I had an entire social media application, because that's the example that's given. Imagine the number of key value attributes that I can make out of it. So many, and I can use them to compare different users. So yeah, it's common in social media applications, as I said, and especially LinkedIn. So let's see how it is similar in LinkedIn. Um, okay, let's go to LinkedIn. I've opened up LinkedIn here. Okay, so this is my account. So okay, so now for example purposes here, I'm using the example of education. Okay, so this is education, right? So now what the my account is saying is that I've done my education at PSBB and PS University. So now let's go back to our PPT here, and one second. Right. So now as I mentioned before, our my education is PS and PSBB. So let's say that I am Arjun and we are comparing me with another person X. So LinkedIn is comparing me with another person X to see if X can be recommended to me as a connection on LinkedIn. So since various key value attributes can be compared, maybe my bio can be compared, maybe my you say what is that certifications can be compared, whatever certificates I have, maybe my projects can be compared. All of these are various keys to go about, and also we have education. So now, as I said before, it can be visualized as a key value pair. So let's visualize this. So I can put PS and PSBB. Now, the people who are going to be recommended to me as a for a connection or as a connection on LinkedIn will be people who have similar education. If the content-based algorithm is using education as one of the parameters for its similarity. Similarly, if the content-based algorithm is using projects and certifications and bio and they all are similar with the person X, then X is going to be recommended to Arjun. So I hope you guys understood this visualization. It's just a simple key value pair kind of way of explaining that I've used. Okay, yeah. So now this diagram is another way of showing you guys. So this is a user A. One second. Yes. So this is your user A. This is your user B, C, and D. And here we have items, and the items are a bunch of movies. So this is Jurassic Park, the first one, and this is The Matrix, the second one. And here we have a few other movies as well. So now let's say that person A. Now these numbers on the arrows, there's a magnitude of I'll tell you what exactly. So person A and comedy on a scale of 1 to 5. Okay, let's consider a scale of 1 to 5. How much does person A like comedy? On a scale of 1 to 5, the person A likes comedy at 3. But for action, it's only 0. Okay. Now let's go over here on this side. So the Matrix. How comedic is the movie? Is the movie comedic at all? I'm sure a lot of you guys would have seen the Matrix, and we know that it's not at all comedic. So this is a big 0. But is there action in the Matrix? Of course, there is action in the Matrix. So this is 4. So now we use this to perform a content based algorithm. So this 3 into 0 plus 0 into 4 is equal to 0. I'll explain what that is. So basically, we're trying to find out here how similar is this movie, The Matrix, and wait, the user's likings. Okay, we have established that the user likes comedy to an extent of 3 out of 5 and action to an extent of 0 out of 5. So we'll multiply that though this 3 into 0 and 0 into 4. So this 3 into 0 is showing this relationship, and this 0 into 4 is showing this relationship. Both of those will be multiplied, and that will be giving 0, which shows that there is absolutely no chance that the user will like the matrix at all. And that is pretty evident from whatever values that are written over here, right? It's pretty evident. So this is one simple way of calculating the how similar or how likely a user is to like some particular item. That is a brief introduction on both your collaborative filtering and content-based filtering. So let's delve into a practical example now. I'll take out the practical example. One second. Okay. So yes, as I mentioned before, the example that we're going to be looking at is a book recommender system. So so I just want to mention what are the data sets that we're using in this book recommender system. And I hope you guys can see this. The data sets we're using is books.csv, and we have ratings.csv, and we have users.csv. We're using 3 data sets for this book recommender system. So to show you guys what the data set looks like, this is what books look like. We have an ISBN associated with it. We have a title of the book. We have an author associated with it. We have a year of publication as well, and we have the publisher. And these image URI, URL, this is the URL short format, URL medium format, and the URL large format. All of these are basically images, and the reason why there's images in this data set is because usually, as I mentioned before, recommender systems are always integrated with a website or some other form of a larger application. It's not a standalone project. It should be used in the larger scheme of things, right? So that is why there's an image over here, because these images will be used in the front end. But since I'm only explaining you the code of the recommender system part right now, we don't have to be that concerned with the image part. We won't be using it. Okay. So that is what the books data set looks like. This is what the ratings look like. It's just the user IDs, the ISBN number, and the book rating. Like whatever rating this particular user has given a book of this ISBN. So you can see that the user 276725 has given the book starting with ISBN 0345 a rating of a big 0. So I just want to bring you guys to the show you guys that ISBN and the ISBN that is over here are same. So that's one potential attribute upon which we can join these two tables. I hope all of you guys are aware of joins. We also have another table for your. This is for ratings. So sorry, not ratings. This is for users. We just saw ratings. This is for users. So here we have the user ID, we have their location, where their place that is, and we have the age associated with that specific user. So using these 3 data sets, we can make our inferences, and we can create a good solid book recommendation system using cosine similarity that we have learned. So this particular coding example, it's slightly long, and it's making use of collaborative filtering. So, but one thing which I want to tell you guys before we start the coding example is that it's highly important that you guys perform extensive exploratory data analysis on any data analysis related project, or because these EDA this what the full form of EDA is what I just mentioned: extensive data, all that stuff, exploratory data analysis. Sorry. So yeah, so EDA helps you find out what are the dependencies in the data. So suppose here, if I'm performing extensive EDA, I can see how if I vary some particular attribute of any of the data sets, how an other attribute will vary, stuff like that. Basically, the dependencies that's there in the data set and all those kind of things we can find out by doing a lot of EDA. It's an entire section under data analysis, and we won't be covering that at the moment. And as I mentioned to you guys earlier, I've tried to keep this workshop as beginner friendly as possible. So there's a lot of comments and there's a lot of texts that are there to explain as much as possible with respect to the code. So here we even explain what the libraries over here do and what they are. So let's dive into the code now. Yeah, so the first thing which we're doing is we're just importing NumPy and Pandas. We'll be needing these two libraries for performing various operations. So both of these are they have a lot of tools which we'll be requiring for various mathematical operations and for other data frame related operations. I've given the write up over here. Please look into it for more information. Okay, so the first thing which we're going to do is we have to read the three data sets that we have loaded into our code. So of course, since this is a short workshop, I've already run out the code and I've gotten the output and kept it so you guys can see it immediately. So right, the first thing is we're going to load the books.csv file into books, that is over here. And we're using the read CSV method to do that. This is a part of the pandas library. Similarly, we're doing the same for ratings, that is down here, and we're doing the same for users, that's down here. So yeah, the all the three CSV files you can get from Kaggle. So if you guys want the code, if you guys want the data sets as well, I'll link it in the comments. Please let me know. So now the first thing which we're going to do is let's see what every single data set looks like. So we're calling we're calling the head method on this data set. So we're calling books.head. What this does is it just returns the top n various rows or tuples that's there in our data set. So this is just to give a general overview of what the data set looks like so that we know how to go about our code. So if I specify some random parameter over here, suppose if I specify 10 or if I specify, let's say 100, the corresponding number of tuples will be returned. But by default, by default, 5 is returned, as I mentioned over here. Okay. Yes. So that is what the head method does. Similarly, we're calling the head method on all the data sets we have. So users, ratings, just to get a general overview of what the data set looks like. Okay. Now, what does the shape method do? So now the shape method is just used to find out the number of rows and columns a dataset has. Right. So all we have to do is just call ratings.shape. And as you can see over here, we have a ratings dataset. It's going to return all the rows that our dataset has. It just goes on. And it's going to show all the columns. Not show all, but it's going to give the count. So that's what it gives over here. It's saying that uh, this is around 8 lakh 5,641 rows or tuples, and we have 3 columns. So it's a fairly large data set. And then we have books.shape. So this has around 58,972 rows or tuples, and this has 8 columns. So we're just calling the shape to see like what is the size of the data set, how much are we dealing with. Then coming down over here, so I'm not called ratings.shape because it's just going to show you the same thing. But I think ratings, I'll tell you guys how much ratings has soon enough. But if you guys want to know, you can just call ratings.shape and we can see the size for it too. What this ratings dot is null dot sum does is that it basically groups the different columns. So here you can see that you have user ID, you have ISBN, you have book rating, you have all the different columns that are there in your ratings data set. So this is the ratings data set, everything is there. It's grouping them and it's sitting and counting how many null values are there in them. So you can see that user ID has absolutely no null values, but ISBN and book rating have just one null value each. Well, that is fine. I mean, that's not a lot. We can deal with that. It's no problem. But if there were a lot of null values, during your exploratory data analysis, you'll definitely have to fill up those null values. One way of doing that is maybe just taking the mean of the remaining number of remaining tuples and substituting that empty value with the mean. That's just a very crude and basic way to do it. There's a lot of other more sophisticated methods which you can use. Um, so you guys can just do some research on that as well. Then you have the books is null dot sum. So now this books is null dot sum. What again? This just shows how many null values are there for the books data set. So we can see that there's only one null value over here. So we're again not too worried about it, especially because we're not even using this attribute in our case. That is the image URL L large. And again, the users is null dot sum. Now this is a problem because in users we have 1,10,762 missing values. That is null values. That is a problem, and we'll see how we can deal with that. And this is about 50% of the age values. So about 50% of those age values are missing. So the total is a double of this. You can check that out by just doing the dataset dot shape, as I mentioned before. So users dot shape will give you the total dimensions. So half of this is missing. We have to deal with this. We'll see how. Okay, and for your reference, I've printed out users dot shape over here so that you can see that it's around almost, not precisely, but it is almost half. Again, we're checking for duplicates in ratings dot duplicated dot sum. So here we're checking for any duplicate tuples, that is. So you can see that ratings has no duplicate tuples. That is, the entire row should not be duplicate. And here again, books, it also does not have any duplicate tuples. And users also does not have any duplicate tuples, which is good to know. So it'll be easier to work with our data. Yes, so this is just very basic exploratory data analysis. In reality, you can and should be doing more to get the best results. But as I mentioned over here, we'll stop the EDA now for now, and yeah. So for a book recommender system, our data set is fairly large. So there may be many books that are not read by a lot of the users. So the thing about that is that it may be irrelevant in an application because there'll be so many books that no one has read. So if we sit and consider all those books for a recommendation, it's going to be very time consuming and it's going to be very inefficient. So what we're doing is that we're considering just the top 50 books. So that's what this slide is stating. We're considering just the top 50 books as per their ratings. Okay. And to further ensure that the most relevant books are chosen for analysis, we consider only those books that have a minimum of 250 copies rated. So only 200, they should be rated minimum, there should be a minimum rating of 250 essentially by the users. And we're considering only the top 50 books according to the rating. So these are two things which we're doing to, shorten the data set and make the task a bit easier. So now, as I mentioned before, I put a special focus on the fact that your books so this is your books data set, and this is your ratings data set. Both of these had a common column, that is ISBN. So now all of you guys have some knowledge about joins, I'm hoping. If you guys don't, check out what joins are. It works on the same concept. So we're essentially merging the ratings and the books. Oh, sorry, the ratings and the books data sets. We're merging those two on the common column ISBN. Okay, and we're creating a new data frame with that called ratings with name. So now your ratings and books, they have been merged on ISBN, and this will eliminate all the books that do not have any ratings associated with them. Because if books do not have any ratings associated with them, then the merge won't take the merge will take place, but there won't be ratings, and we can just eliminate them. So yes, and now we are creating another new data frame, that is your number of ratings data frame. So this is going to find out how many ratings a book has gotten. Okay, so number of ratings data frame. All what we have to do is we have to group by the book title column. So as you can see over here in this output, we have book title, and we're applying the count operation on that. Okay, so now that count operation is being applied over here, and we're calling that as num ratings, right? So exactly what this particular code cell is doing. It's essentially renaming the column, and it's creating a new column called num rating. So the book rating and num ratings will be the columns, and this particular column is just an index. So we can see that by applying those above code cells, when we print out the num rating data frame, that is the number of ratings, every single book and the associated number of ratings they possess is neatly printed out. Okay. So now we know that it takes two. It has been rated twice. And beyond IBM, leadership, marketing, and finance, that's been rated once. So it makes it fairly easy to see which are the more popular books and which are the less popular books. Right? Now the thing is, we not only want the num ratings, but we also want to find out the mean of the ratings each book has got in as its official rating. So the thing is here, maybe for let's say the book it takes two. It may have 1 and 2 ratings, but one user may have rated it 10 and another user may have rated it 2. So we want to even this out by taking the mean of those ratings. That is what we're doing over here. We're printing out the average rating. The average rating has been formed by taking the mean. After grouping by the book title, you're taking the mean and you're finding out exactly what the average is, right? And again, here you're renaming and you're introducing the columns as book rating and average rating. So we print that out over here and we can see that we are clearly getting the average rating for the books. A Light in the Storm, the Civil War Diary of something something, that has an average rating of 2.25. And here you can see that although Beyond IBM Leadership, Marketing, and Finance has been rated, say, where is that? I think it was rated one time over here. It has an average rating of 0, which means that the user which rated it has 0. So this gives us some more inferences we can make on the data and makes our entire job a lot easier. So now using this, what we're going to do is we're going to create a new data frame called the popular DF. Okay, the popular data frame. So we're merging the num rating data frame that we made and the average rating data frame that we also made. These are the two data frames that we made for analysis. We're merging them on the common column book title. So again, I encourage you all to check out how this merging occurs, check out how joins work. So it'll give you a clear understanding if you're not aware. So now because we have merged them, we now have the book title, the num ratings, and the average ratings columns. So now for every single book, for every single item, we have the number of ratings associated with it, and we also have what is the average rating associated with it. So now we have two important parameters which we can go by ready with us. So you can see here that it takes two. It's been rated twice, but both the users would have probably given it a rating of 0, which is why the average is 0. That is why it's important to consider a lot of parameters. Like here, if you had considered only the num ratings, right, then maybe some books would have been rated some 8 or 9 times, but the average rating would be just 1.5. So if you had gone by num ratings, it would have been a very popular book because it's been rated so much, but the average rating gives us a better picture. So similarly, since this is a very simple example, we're taking only two, but in real world examples, you guys should have a lot of different parameters to evaluate on, so that you get a clear picture of the entire process and what is going on. Right. So again, I hope you guys are focusing a lot more on the concept. Don't worry that much about the syntax of the code, right? Because it's the concept which you guys should understand at this juncture. So now the popular DF, that is a popular data frame. What we're doing with it is that we are taking only those books that have the number of ratings of greater than 250. I stated earlier that we're considering only those books that have been rated more than 250 times. So this command does exactly that. And we're also sorting the books by their average rating in a descending manner. This ascending falls, that basically means that we're doing it in a descending way. It's just general Python syntax. I'm pretty sure all of you guys know that. So as I've said over here, we're selecting only those books that have been rated 250 or more times, and we're sorting them. So here you can see that now in this earlier table over here, we had a lot of these. See, we had so many different rows. We had 53,074 rows, and from all those rows, we have chosen only those tuples that have a number of ratings greater than 250, which is what we're getting over here. That has greatly brought down our problem size. It's got it down to only 80 rows. That just shows how many books are not rated that much online. I mean, like, it's a pretty viable statement, right? Because I'm pretty sure a lot of you guys haven't rated books online. I personally have never rated a book online. So, although I have read, I've not rated. It's not everyone rates, right? So, that is something to take into account of. So, here we have the number of ratings, and here we have the average rating as well. Okay. Now, the next thing is popular DF. Now, what are we going to do with this popular DF? As I told you guys, we have done all these operations, taking the ones which have been rated more than 250 times, sorting them in a descending manner, and now we're just calling the head 50 on it. This is because, as I mentioned earlier, we want only the top 50 books. So if I call head 50, it's going to return just the top 50 books. So I've applied head function to it, and now I have a much more succinct, problem size to work with. I have just 50 rows, and they're all high quality books because they have high average ratings, and they have a lot of ratings in number wise, right? So you can see here clearly the average rating is what has been sorted. It's been sorted in a descending manner. So let's go to the next portion of our code. Oops, yes. Okay. So the next thing is we want to display all of the information that is there regarding these top 50 books, right? So we have gotten the top 50 books, but the popular DF data frame that we made, it doesn't have all the information we have in our dataset with respect to these books. So what we're doing is we're merging this entire books data set. You can see here there's all these details: the ISBN, book title, book author, year of publication, publisher, and the image URLs. All of them will be displayed now because we are merging on the book title column, right? So we're merging on the book title column. All of them are going to be displayed. Every single detail with respect to a book is going to be displayed now after doing the merge operation. As you can see here, we have book title, we have the number of ratings, average ratings, everything is there. And we're also dropping the duplicates. So this removes any of the duplicates that may have been formed, the duplicate tuples. Okay. This is because maybe the same book might have appeared multiple times in the data set. This is just a precautionary measure, right? So let's move on. Okay. So now so here we made all those modifications to the popular DF data frame. So now to that data frame, now what we're going to do is we're merging the popular DF data frame on book titles. That is an operation which we already performed, and we're dropping the duplicates. But now what this statement is saying is that let's consider only the columns of book title, book author, image URL M, number of ratings, and average rating. So this is just another pre-processing step. Is just removing all the unnecessary columns that we had over here. Like, we had all these unnecessary URLs. We just took one URL now, that is the medium sized URL, and we are working with that. We've also removed the ISBN that is over here. We don't need the ISBN anymore, so we've removed the ISBN. So that is what this is, just another something to make our life easier. So yeah, so now we have the book title, we have the book author, image URL, and the number of ratings and the average rating. So now let's see what happens. Okay, so now this is from where our collaborative filtering actually starts. I hope you guys all remember what collaborative filtering is. We took 2-3 examples and I've explained it to you guys. So again, to recap, I am Arjun, and suppose you are a user Y, and if I like, say I like, let's say that I like movies, I like superhero movies. Let's say, so let's say that I like the Dark Knight trilogy, all the three. Let's assume in my list of liked movies, and you guys like maybe let's say romantic movies, right? So let's say X likes romantic movies, and somehow the algorithm has found out that me and X are similar. Then maybe the algorithm will start recommending me romantic movies, and X will be recommending movies that I like, that are superhero movies. So that's just a basic recap of what collaborative is. If you guys have forgotten, please go back and watch that section again. So yeah, now in this collaborative filtering approach, what we want to do is we want to select the users that have rated more than 200 books. Okay, we don't want to see, like, a lot of the ratings that are given to the books, they may be from people who aren't actually like passionate readers. Maybe they just read one book and they just randomly rated it on some source online. But we want the opinion of those people who are actually genuinely, crazy readers and who are actually passionate about books and they read books all the time. Because those are the ones who will have much more accurate and ratings that make more sense. So that is why what we're doing is we're considering only those users who have rated more than 200 books, and we're going to call them smart users. So let's say that we're creating a new variable x. So now what we're doing is we're taking the ratings with name and we're grouping them by the user ID and we're counting them up. So I'll tell you what this guys is. Let me just highlight it. Yes. So now we're grouping the ratings with name data frame as per the user ID, and we're seeing how many books have they rated. This book rating is going to give a count. This dot count of book rating is going to give a count of how many books a particular user ID has rated. And if that user ID is greater than 200, sorry, if that count is greater than 200, we'll consider them as a smart user. So this is the smart user. So here you can see that all these numbers that are there, these are all the user IDs. This 254, this 2276, 2766, all and so on. All of these are the user IDs of those readers who have rated more than 200 books. So here we're just printing it out in a much more succinct way. So whoever is not satisfying the condition we mentioned earlier, that is they should have rated more than 200 books, they have a boolean value of false associated with them. They're not a smart user. So a majority, as you can see, are smart users. There will be a few trues in between over here. This is just again to make our problem statement much more succinct and easier to work with. So now what we want to do is we want to identify all the rows where the users are smart users. Okay. So that is why we're going to again go to a ratings with name data frame, and we're going to only select those rows that have user IDs, this user ID that is a part of the smart users that we have found out earlier. And we're going to take only those and we're going to put all those tuples into a new data frame called filtered rating. Okay. So now we're going to be working with filtered rating. This gives a much more clearer picture, like who are the smart users. Filtered rating has the tuples and all the details of all the smart users. So now we're going to identify the books that have, uh, more than 5 ratings. Okay. So all the books that have more than 5 ratings amongst the books that we have narrowed down earlier, we'll assume them to be called as famous books. So now we're going to call y is equal to filter rating dot group by book title. And again, we're counting how many books have been rated more than 5 times. Okay, so all that is going to be fed into y. And these lines are just for some formatting purposes. And we're printing out famous books. And now we're getting an entire list of all the books that satisfy these conditions. That is, they have more than 5 ratings. Okay. So we have Murder of a Sleeping Beauty, we have Salem's Lot, we have a lot of other different books over here. So I hope you guys understood what is happening in these steps. We have significantly narrowed down the data set into something which is much more, clearer now. So now let's identify the details of all the books of the famous books data set. So now we have created this new data frame called famous books, and let's sit and identify the details of all the books. So now final rating, we're creating this new data frame called finals rating, and we're going to select from filtered rating only those books that are a part of the famous books. And we're printing out final ratings over here. We're printing it out, and now you can see that this table is going to contain only those books which are a part of the famous books, and they have the associated user IDs with them, the book ratings, the book title, the author, year of publication, everything. All the details is there and is given. Everything is there for us to see, including the images for integrating with your front end easily. So now let's create what is probably going to be our final table in this code, which is a table with only smart users and famous books. So what we're going to do is we're going to use something called a pivot table. Okay. So now this pivot table, it essentially makes things easier to format. Like you can see over here, we have the book titles as column, and we have the user IDs as your rows. So this is easy to format. It's essentially a user item matrix again. This pivot table helps things be represented as a matrix. So this PT is going to be equal to final ratings final ratings dot pivot table, and your index is going to be book title. So this index is going to be book title that represents what we're feeding over here, and columns is going to be user ID that represents what we're going to feed over here as the columns. My bad. The book titles are the rows and the columns are the user IDs. I might have mentioned the reverse when I said earlier. And what are all the values that are being fed into the code cells? So like, these are called the this 00, this 00. All these are the cells of the matrix. So all of those values are going to be the book rating. So what this pivot table is essentially going to do is it's going to, so let's say that we're considering Salem's lot. Salem's lot is the book title, is going to see the corresponding user ID. So let's take the user ID 189835. And it's going to see what is the corresponding rating. So you can see that the rating corresponding to it is 5.0, guys. So you can see that this is a very sparse matrix. So this essentially means that there's not that many relations between smart users and famous books. That just shows how there is such a wide gap. Like not every user has read every book. So we're getting a very sparse matrix. Of course, in these dots that are over here that represents more rows and columns, you can't see all the non-zero values, but you can see one over here. Here you have a 5.0, and that is the only number value in this, whatever we can see. But so yeah, that is essentially what the pivot table does. So the pivot table is a very useful feature, helps things put things into perspective. So now we are actually going to be using cosine similarity. Now, in when I taught you guys cosine similarity earlier, we did all that mathematics, right? But in Python, using cosine similarity is actually fairly easy. Cosine similarity, you have to just import it from a very important library called scikit-learn, and this scikit-learn can be abbreviated in Python as sklearn. So from scikit-learn, we're importing this cosine similarity. I hope you guys remember what cosine similarity is. It is in this slide. So let's just go up there. Yes. Okay, right now it looks a little dirty, but when I explain it to you guys, I hope you understood. So here you can see what cosine similarity is. This is just the generic formula for it. So what we're doing is we're calculating the cosine similarity. So on these this pivot table, right? On this pivot table, we're calling the cosine similarity method, and we're feeding the data into a variable called similarity scores into an yes into similarity scores. So now here, what similarity scores is going to do is that it's going to tell how similar each book is to other books in the pivot table. Okay, so here you can see that you have so 1 point. So wait 1 second. I have to just highlight. Yes. So we're starting with the first book. So now this entire row, you can see this entire row, right? This is one element within the array, and this is another element within the array. So now what this is doing is that this array is telling you what is the cosine similarity scores between the first tuple in the in the first element in the PT table and all the other books. So the first element was Murder of a Sleeping Beauty, River Mysteries. So here you can see that this entire element or this entire list within the array, it's telling you how similar that book is with all the other books. So the first value is 1. I'll tell you why it's 1. That's because Murder of a Sleeping Beauty is being compared with itself in the first element over here, which is what's giving it a value of 1, because of course the same thing will be similar. Now this 0 point something something value, which we are not able to see over here, that will be the comparison between this Murder of a Sleeping Beauty and this Q space Star Trek book. That is the cosine similarity value. Similarly, this third value over here, that is going to be giving you the comparison between this book and Salem's Lot. All of this has been computed by calculating the cosine similarity across this entire user item matrix. I've showed you guys an example for a smaller matrix. Now, similarly, if we move on to the next tuple, the next list over here, this is going to give you the cosine similarity between the second element with itself and then all the other elements. All the other books that are following it. Okay, so that is how you use the cosine similarity. It is efficiently done, and we can move on now. So yeah, now the similarity scores, the this thing that we have created, we're just calling the shape. So you can see that it's a perfect square matrix. We have 8256 rows and 8256 columns as expected. So now here you can just you can see how similar suppose if I just pass some random value 1 2 or 3, here I pass 4. This is just going to tell you how similar the fourth book is in the in the pivot table to all other books. So here I'm calling this array. Sorry, this array is basically telling you that okay, the fourth book. The fourth book is, let's go up over here. So 0 1 2 3 4. Okay, £10 penalty. So the first value in that array will be how similar £10 penalty is with Murder of a Sleeping Beauty. So that is why here you can see that it is some 0 point something something. That is the similarity that is computed. And similarly, so on, we have computed for all the other elements with respect to the fourth book. So I hope you guys understood how to use cosine similarity. It's very easy to implement it in your code. You have to just call it and you have to import it and you can use it. So now here, this code is just going to tell you the most similar books. That is the top five books based on cosine similarity with respect to the book at the fifth index in the PT array. So that the reason why I've used 1 to 6 over here, well, that is because let's go back up. 1 second, I'll just finish explaining this code. Okay, yeah. So here we're creating this kind of comparison. So here you can see that this over here are the IDs, and this is the similarity score. These are all your similarity. The values that is after the commas are your similarity scores. So you're getting the top five most similar books, and you can see that the most similar book to the fifth the book that is at the fifth index, that is 0.761, and that is fairly close to 1, so you can say that they're somewhat highly similar. This 0.761. Okay, and now we are actually coming to our recommend function. So now, how does this recommend function work? It's very simple. The first thing which you have to do is you're going to take in the book name as a parameter for your recommender, and this code is just going to locate uh, what index the book is at in the PT table. So it's going to go to your PT table, that is all the way up over here, and it's just going to see at what index is present. That's it. So it's going to find the corresponding index values, and then it's going to compute the similarity scores for that particular index values. So this line is the same thing that we're doing over here. Okay, what we're doing is we're just trying to find out the top five most similar books. This particular line and this particular line are the same thing. We're just trying to find the top five most similar books, and we're printing them out. This is just a for loop that is printing them out. So here you can see that when I passed a book called Mating, I'm getting the top five most similar books to Mating using that recommend function. So the reason why Mating is being printed again is probably because there is another version or another volume of the book. Otherwise, we've removed all the duplicates, so there's no reason for it to come again. So I hope you guys understood this basic example. So as you can see, there is a lot of pre-processing that you have to do when you're dealing with recommender systems, and this could be a full-fledged application if you guys can integrate it with some sort of front end. So similarly, in the hackathon, suppose if you guys are making a recommendation system for something like, let's say, a depression detection mechanism, right? So in a depression detection mechanism, you'll probably want to recommend some form of antidepressants that a user can take. So you can create a website and you can be like, enter what you're ailing from, or you can ask the user to enter what the doctor's prescription is, and the website will be able to recommend different medicines to you or something like that. Like it'll recommend you what you can buy or recommend you what prescriptions you can take. This is just a general project, and if you want to make it even more secure, you can probably host the user's data on a blockchain network, or you can maybe cryptographically encrypt it and send it to some secure database. Various things can be done. So you can see the recommender systems, if you're integrating it within the larger scheme of things, you get a lot of points for novelty and a lot of areas for innovation. There's a lot of locations where you can really innovate and make something different. So you can even create a website where you can ask a user to just vent, like literally just vent, and then maybe the website can take in that as input to its recommendation algorithm, and suggest YouTube videos for you to watch to make yourself feel better, like something which like AI is trying to do its best it can to make the user feel better using recommendation algorithms. So like these are some of the various ways you can integrate it with something in the larger scheme of things. So okay, so let's. I just want to before I go, I just want to tell you one more thing. So far we've spoken a lot about ratings, right? And I just want to mention that there are two ways in which you can actually take these ratings. So I told you guys about maybe the user has rated this book this much and so on, right? So there are actually two broad classifications to ratings. The first classification is explicit, and the other one is implicit. Of course, these can be further subdivided into things like continuous ratings or interval based ratings, all those kind of ratings. It can be subdivided. But these are the two main broad classifications of your ratings, right? So now your explicit ratings. So these are things which are actually provided by the user. So let's take the example of Zomato. Okay. So Zomato periodically will ask the user to rate it from 1 to 5 stars. And using whatever rating Zomato is giving for some item, or maybe for the application itself, or maybe for some service that the user experienced, Zomato will store it and will use that for its future recommendations for that particular user. This is explicit ratings because Zomato is actually asking the user. There is direct user participation over here. That is why it's explicit. But implicit ratings would be, there would be no, like, absolutely no direct user participation. Yeah. So there will be no direct user participation. So maybe suppose you have a website, like a random shopping website. So let's call that website SW, which represents shopping website. And then we have the website has a mechanism called a counter. So maybe what the shopping website can do is that it can see for each particular user how many times the person is logged in. So let's say we have a user A and we have a user B. Every time the person logs in and spends some specified amount of time, for that user, the counter can increase its tally, like how many times the user has entered and so on. And it can see what the user has purchased, and similarly, it can recommend future things to that particular user. Same thing can be done for a different user B. So here you can see that this has no direct user participation, it's happening implicitly. Implicit ratings obviously will help you curb the core cell problem to an extent. So that finishes off the small workshop that we wanted to conduct for you guys. I hope you guys understood from this workshop what collaborative and what content based filtering and all those things are. And if you guys have any more questions or any more doubts, any more material that you want, or any of the code that I've showed you guys, if you guys want the link to it or something, please pin me in the comments and I will send it to you guys. I hope you guys have a really good day ahead. Thank you guys so much.